All right, good afternoon to everyone. Akshit, good afternoon. Tanish, good afternoon. Shubham, good afternoon. And who is again left saying good afternoon? Trapti, and then Priyanshi, Deepal, Kirtan, Himanshu, all present. If you are present, says present, sir. Okay, all right. You all present. I hope you all present. All right, today we are going to discuss first before going to any chapter, any topic. Just we have word of prayer, then we can start. Okay. I hope video is clarity was there or not. Yes, Jinisha. Good afternoon. Can you tell to me whether clarity is there or not? Okay, 4 likes means only 4 students are present. Let me know how many are present properly. Clear, okay. Deepal now present. All right, just close your eyes. Let we have word of prayer, then we can start. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. All right, so I want everyone need to pray. The reason behind that, you are observing that this corona was increasing in one side, on the side because of the rainy season, many places are flooded, or many areas are flooded. So what you all need, I'm requesting you all just pray for them so that it will be good. Okay, God will take care of them. All right, Priyanshi, good afternoon. Deepal, good afternoon. Janisha is also present. Okay, so 1, 2, 3. So now, yesterday I was given last 2 problems or homework. That is 10th and 11th. Did you got any doubts in that? If you are not having any doubt, we go for our next topic, vector or cross product. Vector product or cross product we are going to discuss. So you just inform to me. If you have any doubts, you can inform me because already solutions are available in the description link so that you just check. So all the links are available, not in this previous video description link place. You are going to find all the solutions of your exercise number 2. Tanish having doubt. What is your doubt, Tanish? You can ask me. 11th question you have doubt. Okay, what is your doubt in your 11th question? So where you are finding as a difficult in the 11th question? So, okay, you want teaching? Okay. So the vectors, 2 vectors, it is the given, use the vectors, prove that sum of square of diagonals of parallelogram, here they said, sum of squares of diagonal of a parallelogram is equal to sum of squares of their sides. Sum of squares of their sides. It is very easy. Just observe carefully on the board, then you can understand clearly. Okay. So let me take now OA, B, and this will be the CD. So it is a let OACB is a parallelogram. So it is OA OA vector is nothing but A vector. OB vector is nothing but B vector. Okay. So OA vector is equal to A vector. OB vector is equal to B vector. Now I need to find diagonals OC and AB. So you know that opposite sides of a parallelogram equal. So here B vector means this also B vector. If it is A vector, this is also A vector. Okay. So here what you understood here it is OA is nothing but A vector, OB is nothing but B vector. Opposite sides are equal in a parallelogram. That's what the reason. OB vector is equal to AC vector, OA vector is equal to BC vector. So now this is equal to BC vector and this is equal to AC vector. Okay. So now that means here it is arrow mark, here means that also the same method. Okay. Now observe carefully what I will do here. So first one, OC I need to find. How to find OC? According to the triangular rule. So A vector plus B vector in the same directions are there, so that OC vector is nothing but A vector plus B vector. So now we can write OC vector is equal to A vector plus B vector because directions are same. So you are observing A vector going in this way and here again it started same method only. So it is in one circle. If we take these both directions are same. So that was the reason OC vector is equal to A vector plus B vector. Clear now? Up to here any doubt? So no doubt, right? So now we go for another diagonal. O, A, C, D. So this is AB is nothing but one more diagonal. Here see B vector and it is A vector. How to find AB vector? So AB vector is equal to B vector. Now check carefully. This was opposite direction and A is also this A vector and B vector are opposite direction. Because of that reason, for A vector you can write minus A vector since opposite direction. Clear? Up to here, I don't think you have any doubt. So now I'll go for diagonal squares. So I'll rub this diagram. This diagram I'm going to rub. Now, what are diagonals here? OC and AB are diagonals. According to question, sum of the square of diagonals of parallelogram. So here sum of square of diagonals. So here one diagonal OC. So OC vector square because they said square of diagonal plus another diagonal AB. So that AB vector square is equal to what we get. So now what is your OC vector? OC is nothing but A vector plus B vector. So right here A vector plus B vector whole square plus AB vector means B vector minus A vector. So write B vector minus A vector whole square. So then A plus B whole square, A minus B whole square. If you don't know that directly, previously I was given one formula. A plus B whole square plus A minus B whole square is equal to 2 into A square plus B square. So just concentrate here. So here A vector plus B vector whole square plus B vector minus A vector. Just alright, there was some call disturbances. It was A square plus B square. So A square means here A vector square plus B vector square. Then what is your A vector? What is your B vector? That you already know. This can I write same thing as A vector square plus B vector square plus A vector square plus B vector square. What I was done, again separately I was written. After separately writing, first take A vector as OA, B vector as OB and write here. So now A vector means here OA, so that OA vector square plus B vector means what is here? OB, so that OB vector square. So sides square came plus, then again A vector means take now this side BC. So BC vector square plus again B vector means AC. So AC vector square. From this, what you understood here? The diagonal square is equal to sum of the sides square we found. So whichever they said that we prove. Now check here. Sum of the squares of diagonal of a parallelogram. These are the diagonal of parallelogram is equal to sum of squares of their side. So now squares of this side are not previously. What is our diagram of diagram? This is your diagram O A C B. So now check carefully. Diagonals are OC and AB, and then squares sides are OA AC. So you check here. OA is there. OB is there. Next one BC. So BC also is there. Next AC. So all are there. So that all sides are going to get clear now. Any doubt in this? Himanshu now came 30 minutes late. All right. So we'll remember it. Okay. You all observe now. Any doubt in this? So actually this is asked by Tanish, right? Tanish, did you get any doubt in this? If no doubt means then we will start our next topic. Yes, clear. No doubt, sir. Okay. No, sir. 10 minutes late. Then why now only your comment I found? Concentrate. Whenever you come, say present, sir, so that I can understand. Because whenever this completing every day, I'm taking your comments as a printout. In that, I was checking who is came first, who went late, and those are things I'm finding. So whenever you come to the live, immediately you say present, sir. All right. Now we'll go for next one, that is vector or cross product of two vectors. So here it is. Previously we learned scalar product. Now we are going to learn vector product. So now we are going to learn vector product, or this another name for this is cross product. Previously we used dot, in that place we are using now cross symbol. Okay, that means multiplication symbol. Okay, directly I am going to explain to you here. A vector cross B vector is equal to, you have formula modulus of A vector modulus of B vector sine theta n cap. So if A and B two vectors are given, then product of two vectors is A vector cross B vector is equal to modulus of A vector modulus of B vector sine theta n cap. Previously we found in the dot product A vector dot B vector is equal to modulus of A vector modulus of B vector cos theta. But here extra is n cap. What is this n cap? So n cap is nothing but it is a which is a perpendicular one. So you listen this carefully. N cap is a unit vector which is perpendicular to both A and B. Okay. So here n cap is unit vector perpendicular to both A vector and B vector. Okay. And if I need to find the angle in this, sine theta is equal to. So here remember carefully, if you want to find sine theta, what is your formula now in this? Sine theta is equal to A vector cross B vector upon modulus of A vector modulus of B vector into this n cap. So sometimes, anyhow, here I'm going to write this into n cap. Okay. Now I want only n cap. So n cap is equal to, we can write it as, actually unit vector perpendicular to A and B is A vector B vector upon modulus of A vector and B vector. This is your n actually. What is your unit vector? That means n cap is equal to A vector cross B vector upon modulus of A vector cross B vector. And you get to know later how to find this all. Okay. So there are important points, and here main important points in the product of vectors. So you have to remember this. I vector I cap cross I cap is equal to j cap cross j cap, that is equal to k cap cross k cap is equal to 0. Means same numbers or like terms cross multiplication always becomes 0. But if you go for that, I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1. So difference between this, this is a dot product. So in dot product, I cap dot I cap, j cap dot j cap, k cap dot k cap is equal to 1. But in this cross product, I cap cross I cap, j cap cross j cap, and k cap cross k cap is equal to 0. This is main important one you have to remember. Okay. So these are the important points which you have to remember. And like previously, how we were found that is, when 90 degrees means what will happen, and if it is 0 degrees means what will happen. Those are already. So I was prepared, and this notes will be available from tomorrow, so that tomorrow onwards you can understand this all. So now, at last I'm going to give for you A vector cross B vector in the matrix form. So I cap, J cap, K cap, A1, A2, A3, B1, B2, B3. So this is what, how to find A vector cross B vector means. By using this we are going to find. Only this much is enough, and remaining we are going to discuss in your examples and exercise problem. Okay. So now I'm going to rub this. Remaining whichever the concepts are there, that we will discuss in the when we are solving examples and exercise problems. Okay. Right. So now we are going to our problems. So today main aim is 16 to 21 problems we have to complete. That is our aim. So let we go for 16th problem first. What is your 16th? Find the value of 2i cap minus 3j cap plus 4k cap cross 3i cap plus 4j cap minus 4k cap. So that means they were saying just find the cross product of this. So to find cross product, already I was explained to you. According to that, A vector cross B vector is equal to, we can write as I cap, J cap, K cap, A1, A2, A3, B1, B2, B3. So here itself I am going to give for you A1, and here it is 3 fours are 2 fours are 8. So here already minus symbol and half, 3 threes are 9, that is minus 9. Okay, just simplify it. So here you are going to get minus 4I cap minus 8 minus 12 minus 20 minus 20 and minus half minus 20 is nothing but plus 20 j cap into minus plus 8 plus 9 17 k cap. So at last your answer is this, that is minus 4I cap plus 20 j cap plus 17 k cap. Okay, so I hope you all understood anything, any doubt in this. It is once again listen how we solved. First I cap I was written, then minus into minus plus 3 fours are 12 minus 4 fours are 16. So then minus symbol, because the second element always it becomes as minus. So minus j cap, and here it is 4 2 into minus 4 minus 8 minus symbol in the formula 3 fours are 12. So same method we solved. So no doubt in this. Okay, so now if no doubt, we'll go for our 17th problem. So now 17th problem. If A vector is equal to 3I cap plus j cap plus 2k cap, this is your 17th one, and B vector is equal to 2I cap minus 2j cap plus 2k cap. Then find unit vector n cap. So n cap is equal to question mark. Perpendicular to both A vector and B vector. Okay, so we need to find only n vector. How to find this n vector? So everyone observe how to find this n vector. Observe carefully now. So now here in this solution, A vector cross B vector, again here A1, A2, A3, B1, B2, B3. Here nothing is there means one should be. Okay. So now A vector cross B vector is nothing but I j cap, k cap, and then A1, A2, A3, B1, B2, B3. Okay. So equal to I cap, J cap, K cap. A1 means what do you know? 3. A2 is 1. A3 is 2. So 3, 1, 2. Next 2, minus 2, 2. So right here 2, minus 2, 2. Okay. So then again same method. Find now A vector cross B vector like previously how you found. So A vector cross B vector is equal to I cap first and bracket. So then minus symbol, bracket j cap, then plus symbol, bracket k cap. So now we are going to write those. 1 into 2, 2 minus, minus 2 into 2, minus 4. Next, 3 into 2, 6 minus 2 2s are 4. Next, 3 into minus 2, minus 6. Then minus 2 1s are 2. Okay, simplify it. 2 plus 4, 6 I cap. 6 minus 4, 2. So minus 2 j cap. Then minus 2 minus 2 minus 6 minus 8 k cap. You got now A vector cross B vector. Now modulus we have to find. How to do that? A vector cross B vector is equal to square root of 6 square plus minus 2 square plus minus 8 square. So this you have to solve. When you solve, what you are going to get? So when you solve, this is equal to square root of 36 plus 4 plus 64. That is nothing but 104. So 104, we can write it as 2 root 26. Okay. So here, first what we found, A cross B vector. So A vector cross B vector. Then modulus of that. That means magnitude of that we found. Then what is, you have formula n cap. N cap is equal to A vector cross B vector upon modulus of A vector cross B vector. That is equal to A vector cross B vector means whichever is there, write that. In this 2 common now. When you common 2, 2 3s are 6. So 3 I cap. Then minus 2 1s are 2. 2 4s are 8. Minus 4k cap upon 2 root 26. 2 get cancelled. Whichever you get, that is your answer. So n cap is equal to 3i cap minus j cap minus 4k cap upon root 26. So simply what we need to do, observe carefully here. Simply here we need to do here A vector cross B vector and modulus of A vector cross B vector, both you have to find. Then n cap is equal to A vector cross B vector upon modulus of A vector cross B vector. That you have to find. Okay. So any doubt in this? So anyone having any doubt in this 17th problem? If you have any doubt, you can ask me right now itself. No doubt? Fastly tell to me. No doubt, sir. Okay. So now we are going for our problem number 18. Nowadays for you all more holidays getting, so you all enjoying, I think, right? So now we are going to the problem number 18. If A vector cross B vector is equal to C vector cross D vector, A vector cross C vector is equal to B vector cross D vector, then prove that A vector minus B vector and B vector minus C vector are parallel. Very nice. This you need to remember carefully. Previously, if vectors are perpendicular, then we can say A vector dot B vector is equal to 0 in the dot product. But in the cross product, A vector cross B vector is equal to 0 when A vector is parallel to the B vector. This remember. So in dot product, A vector is perpendicular to the B vector. We'll get A vector dot B vector is equal to 0. But now what we need to write here, A vector plus B vector is equal to 0 means A vector parallel to the B vector. Okay. So that is about this. So if you have remembered this part, then these both are parallel. If I need to prove what should be the cross product of this, cross product of this should be equal to 0. That means A vector minus D vector cross B vector minus C vector is equal to 0. Okay. So if we are able to prove this as 0, then these both are parallel. Otherwise, it is not parallel. So now we'll take LHS and we'll prove A vector minus D vector cross B vector minus C vector. Just normal multiplication. A vector cross B vector. Distribution property. Next, A vector minus C vector. So now plus A vector minus, sorry, A vector cross minus C vector. So that means we can write here as minus symbol. Clear? Next one. Minus D vector cross B vector. Next, minus into minus plus D vector cross C vector. This is about your normal multiplication. What we done? A cross B. A cross minus C. That is nothing but minus of A cross C. Next, minus of D vector cross B vector. That's what minus D vector cross B vector. Minus into minus plus D vector cross C vector. So now what I need to do here? A vector cross C vector means substitute this because it is given. So in your problem number 18. Okay. So now wherever A vector cross B vector means substitute this. A vector cross C vector is there, substitute this. So what we are going to get, check. So A vector cross B vector. So we can write C vector cross D vector. Next, your minus symbol. A vector cross C vector means what do you know? B vector cross D vector. Anyhow, the minus was there. If I need to change into the positive, what we need to do means if I interchange these both, I can change minus as plus. That means minus of minus B vector cross D vector. Okay, because you already know that that is B vector cross D vector is equal to minus D vector cross B vector. So according to that. So now we can write here D vector cross B vector as minus of D vector cross D vector. Now plus here also interchange what we are going to get minus of vector. So simply remember if I want to interchange this minus symbol you can write front. Okay. Just remember in that. C vector cross D vector minus B vector cross D vector minus into minus plus B vector cross D vector plus into minus minus C vector cross D vector. Now check carefully. Plus C vector cross D vector minus C vector cross D vector, then minus B vector cross D vector plus B vector cross D vector cancel. You get a zero vector that is nothing but zero that is equal to RHS. Therefore, A vector minus D vector and B vector minus C vector are parallel to each other. It is parallel symbol. Okay, so that is about your 18th problem. So anyone having any doubt in this? Very simple, just normal multiplication. After that, just these both, if you want to interchange, you have to keep the minus symbols. Then substitute A vector cross B vector plus C vector cross D vector, A vector plus C vector plus B vector cross D vector. Just substitute it and cancel it, get answer as 0. Okay. Yes, sir. So I also get same answer. Okay, Satish, you are getting same answers. It's very good. Okay, if that the case, community strike. So you all understood this. Can we go for next? Yes, sir. Okay. So now we are going to the problem number 19. Okay. Now, problem number 19. If, very good question it is. If A vector cross B vector is equal to C vector cross B vector, prove that A vector minus C vector is equal to lambda B vector, where lambda is a scalar. Okay. Very simple question actually it is. How it is simple question, just you can observe carefully now. So it is problem number 19. First take whichever given A vector cross B vector is equal to C vector cross B vector. Okay. Here plus symbol, this whole is having plus symbol, comes to your minus symbol. So A vector cross B vector minus C vector cross B vector is equal to 0. And nothing is there, because of that reason we need to keep as 0. So next, what I can do, just observe carefully now. So now just cross multiplication we can do, and what is possibilities are there that we can find out. So what I do here, it is in both. This just you can shift. If I want to shift, what I need to do? A vector cross B vector. If I want to write B as first, C as second, just minus symbol you have to keep. B vector cross C vector is equal to 0. Minus into minus plus. So A vector cross B vector plus B vector cross C vector is equal to 0. So now what I will do with this? So C vector cross B vector. Okay, not required to do that. I went for some other. See here, both places B vector is in the second place only. So that no need to go for that procedure. Directly we can solve. So here in this B vector cross A vector minus C vector is common in both places. That is also both place in the second part only. That's what B vector common, and A vector minus C vector cross B vector written. So after writing this, what we can write in this still? Sorry, this cross product is equal to 0, and still what I can write in this? So from this we can write A vector minus C vector and B vector are parallel to each other. If anything is parallel to each other, what we can write? So we can write it as first vector is equal to some real number and then vector. So that means we can write A vector minus C vector is equal to lambda B vector, where lambda is scalar. Clear? So I hope you all understood this. See, once here, if both are parallel happen, then first one equal to multiplication of second vector. So that is, that number will be, we don't know, that may be the positive or negative, but that lambda is a scalar. When it is positive, when it is negative. So here lambda is positive when A vector and B vector are like, means like vectors, and lambda is negative when A vector and B vector are unlike. Just this, remember, it is just a note. Okay, I hope you all understood this. So if you are understood, we'll go for our 20th problem and then 21 problem. I hope so. You after completion of that, we are going to complete this full. So we'll go for now 20th problem. So you can revise again, pause the videos and revise by your own later. So now we are going to the problem number 20. In this place, points are given: A point 1, 2, 2, B point 2, minus 1, 1, C point minus 1, minus 2, 3. Be any 3 points in a plane. Then find a vector in the direction of perpendicular of plane ABC. So perpendicular to the plane ABC. Perpendicular to plane ABC. So a vector perpendicular to plane ABC, whose magnitude is 5 units. Whose magnitude is 5 units. This we need to find out. So for this, before going to find that, first find what is AB and what is AC. So find AB and AC. AB and AC, and that time you will find that AB and AC. The example I'll draw here some triangle A, B, C. Okay, AB, AC you find. Once if you find AB and AC, so then we are able to find the perpendicular vector to the plane ABC, because AB and AC both are in the same plane only, so that only we need to find this AB and AC product, vector product find. So for finding that, first AB vector. So AB vector, then go for AC vector. How to find AB vector and AC vector? So you already know that x1, y1, z1, x2, y2, z2 we can give. AB means B vector, position of B vector minus position of A vector. And simply we can write it as x2 minus x1 into I cap. So here x2 minus x1 means 2 minus 1, 1 I cap. And next one, y2 minus y1, minus 1, minus 2, minus 3 j cap. I'm writing directly. So then 1 minus 2, that is minus 1 k cap. Same method. Next one, it is B AC. AC. So minus 1, minus 2 I cap. Minus 2, minus 4 j cap. Next, 3 minus 2 is nothing but plus 1 k cap. So we got now AB vector and AC vector. Let's say AB vector as A vector, AC vector as B vector. So now A vector cross B vector find. So how to find it is I cap, J cap, K cap, 1 minus 3, 1. So 1 minus 3 minus 1 minus 2 minus 4, 1. I'm not writing any formulas now, directly substituting, because time is very less, we need to complete within this period itself. So A vector cross B vector is equal to minus 3 ones are minus 3 minus 4 I cap minus this j cap, and here it is 1 minus 2 plus k cap minus 4 and minus 6. So now let me simplify. Minus 7 I cap minus j cap, sorry, plus. At last I got A vector cross B vector as this. Then modulus of A vector cross B vector will find square root of A square means minus 7 whole square, B square means 1 square, and last one, that is minus 10 whole square. So we can write this is equal to 49 plus 1 plus 100, that is square root of 150. So we are going to get that as square root of 150. So once if you get square root of 150, we can write it as 5 root 6. When you simplify, you will get, because 25 6 are 150, square root 25 is nothing but 5, 5 root 6 you are going to get. Once if you get that, first find the a vector perpendicular to the plane ABC. A vector perpendicular to the plane ABC is equal to A vector cross B vector upon modulus of A vector cross B vector. So that you have to write, that is nothing but your n cap. So that is equal to, so A vector cross B vector means write this one, that is minus 7i cap plus j cap minus 10k cap upon, and what about this A vector cross B vector means 5 root 6. So you got this, and now I want whose magnitude is 5 units. So now I can write this as it is. This step you can write down here after writing 5 into n cap. So that means 5 into minus 7i cap plus j cap minus 10k cap upon 5 root 6. 5 get cancelled. So at last what you get? Minus 7i cap plus j cap minus 10k cap upon root 6. This is your answer. A vector perpendicular to the plane ABC whose magnitude is 5 unit is this. So this is your resultant vector. Okay. So that is about your problem number 20. So you can just pause the videos in the offline video and then check back so that you can understand clearly. So let's move on to the last and final problem of today. Last and final problem. Yes, we'll go for that last and final only. So 21st. Prove that vector area of quadrilateral is denoted by half AC vector and cross BD vector, where AC and BD are diagonals. Okay, so I need to prove that area of quadrilateral. This is PT. Area of quadrilateral. Quadrilateral means squared. I am writing. That is equal to half AC vector cross BC vector BD vector BD. So this I need to prove. How to prove? Observe carefully, everyone. Before going to prove, let me rub this part because little bigger matter is there. No space means in the middle difficult. All right. Now we are going to the last and final problem. So in this diagram first, A, B, C, D. So let me draw the diagrams. All right. This is about your diagram. So now I want to find area of a quadrilateral ABCD. How to find? So area of ABCD is equal to, here two triangles are there. If you add those both triangles, then you are going to get your answer. So that is area of triangle ACD, area of triangle ACD plus area of triangle ABC. So I'll take now first only these two, then later. Okay. So this is your first one. This is your second triangle. So area of ACD. Second one it is ABC. Anyhow, you already know that in a parallelogram, opposite sides are equal. So if both should be the parallel also, so that signals, whichever here you are finding, direction should be the same. So your direction should be the same. So direction is same. So means AB and DC direction should be same. AD and BC direction should be. Let me solve this problem, you can understand. So now what do you know area of a triangle ACD? Area of triangle ACD. So what we can write area of triangle ACD means, so area of triangle ACD is nothing but half into base into height. So here it is height or perpendicular is a BC means BC only. So that means what we can write here, it is in vectors, whichever the corresponding adjacent sides are there, those adjacent sides only the perpendiculars also. So now half AC vector. So this is your diagonal AC vector cross AD vector. So if you take ACD, AC vector cross AD vector, okay, plus half. If I take ABC, then AC AB. So now write AC vector cross AB vector. So now here first one it is half AC vector cross AD vector plus half AC vector AB vector. So that is we written first, that is our areas. Then what we can do here it is now. So AC AB is there here, here AC AD is there. Anyhow here first AB, then your AC. So now in this place, first AB, then your AC. Here observe now, AC is in the first place. So here also I need AC in the first place means just interchange. If you interchange, this plus symbol becomes as a minus. So half AC vector cross AD vector minus half AC vector cross AB vector. Now in both what is common? Half AC vector is common. So now write in this half AC vector common. When you common half AC vector, what is there? AD minus AD vector minus AB vector. So AD minus AB. AD minus AB means what is that vector? That is nothing but your BD vector. So directly I can write here half AC vector cross, this is cross symbol, okay, BD vector. So at last area of ABCD is equal to half AC vector cross BD vector. So you are understood this. So first, if I need to find area of ACD, anyhow I'll write again here it is ACD. So if I need to find area of ACD, so I need to write this first starting from here. That's what here it is AC, and next one it is going to be the AD. So point will be A, and whichever the adjacent sides are there, those only we have to take. So first one AC vector, second one AD vector. So the same method now here ABC. If you take A, B, C. So in ABC, first it is AB, then next. So now first take as AB. So then AB vector cross second one is AC vector. So then I want here AC here first place it was 1 means it is the first AC vector is there, but here second place AC vector is there. So that exchange it to interchange you can write plus plus minus. So that half AC vector cross AB vector in both half AC vector is common. So just common that. Then AC vector cross AD vector minus AB vector. AD vector minus AB vector is nothing but since here I'll write AD vector minus AB vector is equal to BD vector. So this is about your area of a quadrilateral half AC vector cross BD vector we proved. So that hence it is proved. So that is about your problem number 21. And still, if anyone having any doubts, just go for your offline video so that you can understand clearly. Still, you are not able to understand, you can WhatsApp me or you can send me a message so that I can again I will made one video and I am going to send to you. Okay, so that is about that. And tomorrow we are going to complete exercise number 13.3. Okay, so tomorrow aim also now only I'm saying. So and this description link means the solutions description link is going to be available within tomorrow. Okay, tomorrow morning within 10 it is possible to be available for you all this one, and all the notes whichever that product, and even here it is I was written for you all algebraic properties also is there. So you just go through it and understand those all things, and it was very easiest one. And if that too also completed, because now time is very less and according to our aim we have to complete up to probability, means this chapter after three-dimensional geometry then probability. So once those all completed, all easy means continuation, whichever not there, those all chapters are going to be completed. And next, whichever is left, those all continuity chapters. Means one day if you are absent also it is not possible to understand next day on. Okay, that's the reason you should be more care. Because of that reason I'm completing first this easiest 10. Actually easy we cannot say, that 10 chapters we are completing, and then we are going to complete remaining all only for your purely your benefit purpose. Okay, so that is about that, and remaining things we will discuss tomorrow. Okay, anyhow, may God bless you all. Anyone having any doubt? No? Okay, what are you all writing? Thank you, sir. Okay, sir. Okay. May God bless you all.